It's always a pain to find spaces for parking our cars. But thankfully, places like shopping malls and movie theatres have exclusive spaces for parking. They are controlled by automatic systems in the high-end places. You might be guessing what systems? Well, these systems can count the number of spaces available for parking in one floor. They can also produce a layout to show which floor has free slots for parking our cars. And do you know the best part? It's the automatic gates. They are automatic and they are controlled by codes that tells them to open when they sense a vehicle coming close. And is there some kind of magic happening? Well, it's due to the presence of a magic component. And it is called an ultrasonic sensor. An ultrasonic sensor is an instrument that measures the distance to an object using ultrasonic sound waves. It measures distance by sending out ultrasonic sound waves from the transmitter and then waits for that sound wave to bounce back to the sensor. The reflected sound waves are received by the receiver. By recording the time taken for the sound wave being generated and bouncing back to the sensor, we can calculate the distance between the obstacle and the sensor. So dear, let's design a circuit for smart gate using servo motor and ultrasonic sensor. And we can use text coding. Since you're familiar with text coding in the past sessions, you can design a circuit for smart gate much more easily. So let's design a smart gate by using an ultrasonic sensor to measure the distance from the obstacle. And accordingly, it can be used to turn on and off an LED. Are you ready to withstand something magical and mesmerizing? Well dear, come on, let's start. To begin with, search for an Arduino in the component library. And then drag and drop it to the workspace. Now, let's add the magic component to the workspace. Search for an ultrasonic sensor in the component library. And yes, here it is. There are 3-pin and 4-pin ultrasonic sensors available in the component library. So let's drag and drop a 4-pin ultrasonic sensor to the workspace. Move the Arduino a little down. So this is the ultrasonic sensor. Can you see the 4 pins of the sensor? They are VCC, trigger, echo and ground pin. Just like any other component, we need to power up the ultrasonic sensor to make it work. And ultrasonic sensors can be powered using the VCC and the ground pin. Now, the trigger pin is the one that emits the ultrasonic waves. These transmitted sound waves hit the target, then bounce back to the receiver of the sensor. And from the echo pin, we can obtain the output. It's exactly like a bouncing ball. You drop one of those bouncing balls against the floor and it comes right back, doesn't it? Yes, so in this case, the ultrasonic sound waves are the bouncing ball and the car is the floor. The receiver is like your hand that catches the ball again. So we can infer how far is the obstacle from the sensor from the output of the echo pin. Now interface the ultrasonic sensor to the Arduino. For that, change the Y color to red and connect the 5V pin of the Arduino to the VCC pin of the ultrasonic sensor. Now change the Y color to black and connect the ground pin of the Arduino to the ground pin of the ultrasonic sensor. Next, change the Y color to green and connect the trigger pin to the digital pin D3. Then change the Y color to blue and connect the echo pin to the digital pin D5 of the Arduino. Now we can add an LED to the circuit just as we did in our old session. Change the Y color to red and connect the anode of the LED to pin D8. Then change the Y color to black and connect the cathode of LED to digital pin D9. Zoom out the circuit and move it left. Now do coding to make the ultrasonic sensor active. Go to Codes. Remove the existing codes as we don't require them. Drag the code space to the left. Let's start by creating a variable so that the input from the sensor can be stored to this. Click on the variable and select Create Variable. We can enter the new variable name as Distance. Click OK. Then drag and drop Set Distance to block to the coding space. Go to the input and then select the Read Ultrasonic Sensor on Trigger Pin block to the Set Distance to block. Move the code a little left. But still we can't see the full block, right? Let's move the circuit left. Then drag the code space left. Now we can see the full block. We have connected the trigger pin to the digital pin D3. So click on the drop down arrow and change the pin number to 3. And the echo pin is connected to the digital pin D5. Click on the drop down arrow and change the pin number to 5. How can we see the output from the ultrasonic sensor? For that, go to Output and select Print to Serial Monitor block and place it in the coding space. Then click on Variables and drag and drop the distance block on the Print to Serial Monitor block. Let's see how the ultrasonic sensor detects the distance from the obstacle. For that, click on Start Simulation. Then click on the serial monitor and we can see a default value. Now move the circuit a little downwards and press the ultrasonic sensor. And you can see that distance is displayed here. The obstacle is 113.2 cm or 44.7 inch away from the ultrasonic sensor. You can also see the distance, that is 113 cm in the serial monitor also, which was the default value. This is the obstacle as you move it. The distance between the sensor and the obstacle varies, and it will be displayed in the serial monitor and also on the sensor. Let's zoom out and drag the circuit down to see the range of sensor more clearly and press the ultrasonic sensor. Move the obstacle again and we can see the change in value. Now stop simulation. Now let's turn an LED on according to the distance between the ultrasonic sensor and obstacle. Go to Control and choose If and Else block. Then place it in the coding space. Go to Math. Drag and drop the relational operator block on the If and Else block. Click on Variables. Drag and drop the distance block and place it on the relational operator block. Our condition is that if the distance between the sensor and obstacle is greater than 100, the LED should turn on. So click on the drop down arrow, change the mathematical operator to greater than and change to 100. Then go to Output, drag and drop Set Pin to block and place it in the If block. Add one more Set Pin to block as the LED is connected to two digital pins. Anode of the LED is connected to digital pin D8 and cathode of the LED is connected to digital pin D9. So click on the drop down arrow and change the pin number to 8 and 9. Let pin 8 be high and set pin 9 to low. Then comes the else condition. That is, if the distance is lesser than 100 cm, the LED should turn off. So duplicate these set pin blocks and place it below the else block and set the pin 8 to low. Click on Start Simulation. Yes, you can see that the LED is off because the distance between the obstacle and the ultrasonic sensor is 56. That is less than 100. Now click on Sensor and increase the distance. Now the LED turns on when the distance between the obstacle and the ultrasonic sensor becomes greater than 100. as the distance is reduced to a value less than 100 cm. The LED turns off. Now stop the simulation. We have done our coding using block coding, right? So let's see how to do the same using text coding. We know how to change blocks to text from our previous sessions, so we are not showing it again. Let's move directly to text coding. So this is the space for us to do text coding. Here there are some text codes which we don't require. So erase the selected text codes by selecting and deleting. Now you can see two text codes and some brackets, right? Void setup and void loop. To begin with, we can initialize some variables above the void loop. Type int trigger pin equal to 3, and in the next line type int echo pin equal to 5. As the trigger pin is connected to digital pin D3 and the echo pin is connected to digital pin D5, we know that the ultrasonic sensor measures the distance between the obstacle and sensor by calculating the time for the echo signal to reach the sensor. So move to the next line and type long duration, then put a semicolon. You might be wondering how the variable int is different from long, right? A variable that an int variable can hold is not too short and not too long, whereas the value that a long variable can hold is long. Then type long, distance, then put a semicolon. We have initialized the variables. Now go to void setup and type pin mode within brackets trigger pin, comma, output. We have defined the trigger pin as the output pin as it receives the signal, and it is based on the signals applied in the trigger pin. The transmitter of the ultrasonic sensor emits the sound waves. Then move to the next line and type pin mode within brackets echo pin, comma, input, then put a semicolon. We have defined the echo pin as an input pin, as the echo pin receives the echo waves after hitting the obstacle. Now we need to turn the LED on. So type pin mode within brackets 8, output. In the next line, let's copy this syntax and place it below, and then change the pin number to 9. Now go to void loop and type digital write within brackets trigger pin, comma, low. As initially we want to set the trigger pin low, then we require a delay of 2 milliseconds. So type delay within brackets 2, then put a semicolon. Move to the next line, then copy the digital write syntax and delay syntax, then paste it below. Now let's set the trigger pin to high. So type high and change the delay to 10. We need to add the delay as the transmitted ultrasonic sound waves hit the obstacle and then only is reflected back to the receiver of the sensor. Then again copy the code digital write within brackets trigger pin, comma, low syntax from line 15 and paste it on line 19. Now call the variable duration. So type duration equal to pulse in within brackets echo pin, comma, high. Then put a semicolon. Make sure that the letter I in pulse in is in capital letter. Do you know the purpose of syntax pulse in? It checks whether the signal from the echo pin is high or low. Here we have to wait until the echo pin receives a high, and time at which the echo pin receives a high will be stored to the variable duration. So now we have written the syntax to measure the time taken for the ultrasonic sound waves to hit the obstacle and then bounce back to the sensor. Now we also need to find the distance between the obstacle and the sensor. So type distance equal to duration multiplied by 0.034 divided by 2. Then put a semicolon. Here duration denotes the time at which the echo pin turns on and 0.035 is the velocity of sound. So why do we divide this value by 2? We know that the duration is the time taken for the ultrasonic sound waves to hit the obstacle and then bounce back to the sensor. So by half the duration, the sound waves will hit the obstacle and hence the distance between the obstacle and sensor can be measured. Now write the coding for conditions. Type if within brackets distance greater than or equal to 100. Then open a curly bracket. Type the code to turn an LED on. We can type digital write within brackets 8, high. Then put a semicolon. Then copy the syntax and just paste it below. Change the pin number from 8 to 9 and change high to low. And close a curly bracket. Here, if the distance is greater than 100, the LED will turn on. We also need to write the codes to turn the LED off if the distance is less than 100. So copy the if condition, paste it below, change greater than or equal to lesser than, and set the pin 8 to low. Now click on Start Simulation and let's see if we have obtained the desired output. Yes, you can see that the LED turns off. Zoom out and drag the circuit down. Then click on the sensor. We can see the distance between the obstacle and the ultrasonic sensor is less than 100. And as the distance is increased to a value greater than 100, the LED turns on. When we reduce it below 100, LED becomes off again. Stop simulation and hide the code space. I hope you understood how to interface an ultrasonic sensor to the Arduino and calculate the distance between the obstacle and the ultrasonic sensor using text coding and block. Now let's design a smart gate system with servo motors and ultrasonic sensors. You might be confused regarding the working of smart gate systems, right? When the distance between the vehicle and the smart gate is greater than 100 cm, the red LED should be turned on and the gate should remain closed. As the vehicle approaches the smart gate, that is, when the distance between the vehicle and the smart gate is between 100 cm and 24 cm, the red LED should blink and the gate should gradually start to open. Finally, if the distance between the vehicle and the smart gate is less than 24 cm, the green LED should be turned on and the gate should be completely open. So this is how a smart gate system works. Let's search for a servo motor. Then drag and drop a servo motor to the workspace. Then rotate the servo motor and place it here. Move the circuit up. Now change the Y color to orange. And connect the digital pin D2 to the signal pin of the servo motor. Change the Y color to red. And connect the 5V pin of the Arduino to the power pin of the servo. Adjust the wire. Then change the Y color to black. And connect the ground pin of the Arduino to the ground pin of the servo. Now zoom in the circuit. Close the search bar. Let's drag and drop an LED to the workspace. Change the color of the LED to green. Now interface the LED to the Arduino. Change the wire to red and connect the anode of the green LED to the digital pin D11. Then change the wire to black and connect the cathode of green LED to the digital pin D12. Now zoom out the circuit and move it left. Let's go to code by clicking the code button. And in order to call the library, let's move to line 4 and press enter. Then type #include servo.h. Make sure the letter S in servo is in capital letters. We also have to set up a variable name for servo. Type servo1 semicolon. Make sure that S is in capital letters in servo, where servo1 is the variable name for the servo motor. Go to void setup and type servo1 dot attach within brackets 2, then put a semicolon. It signifies that we have attached the signal pin of servo to the digital pin D2 of the Arduino. We need to turn on the green LED too. So let's copy this syntax and place it here. And then change the pin number to 11 and 12. Now in the void loop, we have already written the first condition to turn on red LED, when distance becomes greater than or equal to 100. Now we can add a modification here. If distance greater than or equal to 100, the servo should rotate by 90 degrees. And then we need to turn on the green LED, and the green LED must be off. Within curly brackets of the first condition, type servo1 dot write within brackets 90. Then put a semicolon. We have already written the codes to turn on the red LED. Let's now type code to turn off the green LED. Then copy the syntax and just paste it below. Change the pin number from 8 to 11 and change high to low. Then change the pin number from 9 to 12 within the curly bracket. Erase distance lesser than 100 cm condition. For the next condition, we need to change the angle of servo to 67 degrees when the distance is greater than or equal to 75 and less than or equal to 99. So let's change the syntax to if within brackets distance greater than or equal to 75 and distance lesser than or equal to 99. Change the pin number 8 to high to turn on red LED. Then copy the code from line 31 to 33 and paste in line 38. Change rotation of servo from 90 degree to 67 degree. We know that when the distance between the vehicle and the smart gate is between 100 cm and 24 cm, the green LED must be off and the red LED must be on. Third condition. So let's copy this syntax and paste it below. Now we can change if within brackets distance greater than or equal to 75 and distance less than or equal to 99 to if within brackets distance greater than or equal to 50 and distance lesser than or equal to 74. We need to change the angle of rotation of the servo to 44 degrees. In this syntax, servo.write within bracket 67, change 67 to 44 degrees. The red LED should continue to be on and the green LED should be turned to off itself. Similarly, paste these codes again. Change the condition if within brackets distance greater than or equal to 75 and distance lesser than or equal to 99 to if within brackets distance greater than or equal to 25 and distance lesser than or equal to 49. The red LED should continue to blink and the green LED should be turned off itself. For that, type delay within brackets 500. Then put a semicolon. Copy this syntax from line 50 to 52 and paste it below. Change high to low. Then scroll up. We need to change the angle of rotation of the servo to 21 degrees. In this syntax, servo.write within brackets 67 change to 21 degrees. Now we have reached the climax stage. That is, as the distance between the vehicle and the smart gate is less than 24 cm, the gate must be completely open. The red LED should be turned off and the green LED must be turned on. So let's copy this syntax and paste it. Change the condition. If distance greater than or equal to 50 and distance lesser than or equal to 74, to if within brackets distance greater than or equal to 0 and distance lesser than or equal to 24. The gate must be completely open, right? Let's change these codes to turn off the red LED. Change high to low. So we need to change the angle of rotation of the servo from 44 degrees to 0 degrees. In this syntax, servo.write 44, change 44 to 0 degrees. And that is to turn on the green LED. Set digital pin 11 to high. Yes, now a green LED will turn on. Click on Start Simulation. And let's see how the smart gate operates. First, the servo is moving. Click on Sensor and move the obstacle. Increase the distance between the vehicle and the smart gate greater than 100 cm. The red LED turns on and the gate remains completely closed, while the green LED is in its off state. As the distance between the vehicle and the smart gate is less than 100 cm, the red LED is on and the gate initiates to open. As the vehicle is more close to the gate, red LED on and the gate turns open gradually. The green LED remains off itself. As the distance between the vehicle and the smart gate is very close to 24 cm, the red LED blinks and the gate is almost open. Finally, as the distance between the vehicle and the smart gate is less than 24 cm, the red LED turns off while the green LED turns on and the gate completely opens. Now stop the simulation. Wow, this is how we design a circuit for smart gate system using ultrasonic sensor and servo motor. You can definitely see that technology has reached a point where it can definitely ease mankind. So practice whatever we have learned, and I will meet you with much more amazing topics. Until we meet again, bye bye.